Yeah, I'm just watching some of his videos now. They are so cringeworthy. Oh, hang on, I've got to go. Sorry guys, I didn't see you there. Today I actually wanted to go through another example involving simultaneous equations. The other lesson we looked at some simultaneous equations and solving them via substitution. Today I wanted to go through the method of elimination. First of all, though, we'll start with our key ideas as usual, and where we would probably use elimination rather than substitution. You can see here it's got the method of elimination is generally used when both equations are in the form of ax plus by equals d. So you've got the two variables on one side of the equation, that being x and y, and that is in both of the equations. Remember when we started talking about simultaneous equations, it was looking for a point of intersection. We know that this equation, 2x take y equals 6 and 3x plus y equals 10, is a linear equation. It represents a straight line. And if they're not parallel, they'll meet at a certain point. So our answer is going to be a set of coordinates, an x value and a y value, where those two lines meet. So if you do ever come across a simultaneous equation problem, both of your equations are in this form, you've got x and y both on one side of the equal sign, we can use elimination. And I'll go through a few examples. This video might be a bit longer because it is a little bit more, I guess, complex, especially when we're looking at examples B and C. But anyway, let's get started with example A, and I'll walk you through the process. So, again, I've got two equations. Let's start by writing them out. It's x plus y is equal to 6, and 3x take y is equal to 10. Now, what I want to do for elimination is actually find a matching pair. And what I mean by that is a matching pair in terms of my pronumerals. So x and 3x don't match because x in the first equation has a coefficient of 1, x in the second equation has a coefficient of positive 3. But the y values both have a coefficient of 1, one being a positive 1 and one being a negative 1. So what I'm actually going to do, if I label this equation 1 and equation 2, is if I actually add these two equations together, I'm going to eliminate the y value altogether. And that's the idea of elimination. That's why it's called elimination. So let's add equation 1 and equation 2 and see what we get. So x plus 3x is 4x, and y plus minus y, or 1y plus minus 1y, is 0y. So it's actually eliminated itself. Then I'm left with 6 plus 10, which gives me 16. And to solve from there, it's literally just a matter of, okay, here, divide by 4 on both sides. Okay, and I'm left with x equals 16 divided by 4, which is 4. Okay, remember, we're looking for a set of coordinates here, so I need to then substitute 4 back into one of these two equations. Let's go with equation 1 because it's nice and easy. So 4 substitutes back into the equation as 4 plus y equals 6. Okay, again, let's solve. Let's take 4 from both sides. I'm then left with y equals 2. Again, my answer needs to be in a set of coordinates. This time it's 4 for the x value and 2 for the y value. Okay, nice and easy there, guys, because we actually had some matching pairs with our y values. It's not always going to be that easy, and in fact, when you look at question 2, or sorry, example B rather, you'll see that. So let's go ahead and give ourselves some room over here. This time, hopefully you can still see those equations there. Let's go ahead and write them down. Y take 3x is equal to 1, and 2y plus 5x is equal to 13. Again, I'm going to label this equation 1 and equation 2. This time I don't have any matching pairs, so I can't, technically add or subtract these equations from each other to, eliminate the y value or the x value. But what I can do is if I multiply equation 1 by a factor of 2, I will have a matching pair. And it's up to you how you do this. If you can do it in one step, fantastic. And that's what I'm going to do. I'm actually going to write here. So I'm going to do equation 1 times by 2, which then gives me, if I do 2 times y, I get 2y. 2 times minus 3x is minus 6x. And 2 times 1 is 2. So I now have equation 3, and I now have a matching pair. My y values are matching. In this case, I'm not going to add the equations like I did over here. If I just draw your attention back to the first example where I added equation 1 and 2 together, that was because one of the matching pairs was a positive and one was a negative. Here they're both positives. So I'm going to do equation, it doesn't matter how you do it because you'll still get the same answer. Let's do equation 2. Take equation 3. Okay, so 2 take away 2 is gone, it's eliminated. I'm left with 0y. I've then got, let's use red, positive 5x take negative 6x. 5x take negative 6x. It actually equals 11x. Two negatives make a positive, and 13 take away 2 is also 11. Okay, so now I'm at the point where I've got 11x equals 11. Again, we can just divide by 11 on both sides, which gives me x equals 1, or x is equal to 1. From there, I'm then going to substitute the value of 1 back into either of those equations, 1, 2, or 3, doesn't really matter. Again, I like to use a simple one, or the one that's probably the easiest. In fact, equation 2 has got doesn't have any negatives in it, so let's roll with that. So 2y plus 5x, and again, this time x, we're going to use the value 1, so 5 times 1 is equal to 13. Zoom out a bit. Okay, now we solve that, so 2y plus 5 times 1 is 5 equals 13. Let's go ahead and solve for y. Take away 5 on both sides. 2y equals 13. Take away 5, which is 8. Divide by 2 on both sides to remove the 2. Okay, let's cancel it out on the left-hand side. I'm now left with y equals 8 divided by 2, which is 4. So now my set of coordinates here, my answer to this simultaneous equation is set of coordinates 1, 4. Okay. All right. The last example I'm going to do is, in fact, if I can somehow grab that and bring it over here, get rid of all that other stuff, zoom back in, and have a look at question C, or example C. Again, two equations, 3x plus 2y is equal to 6, and 5x plus 3y is equal to 11. This is my equation 1, this is my equation 2. Now, again, I don't have any matching pairs. The x values have a different coefficient, 3 and 5. My y values have a different coefficient, 2 and 3. And in fact, if I multiply one of these equations by a factor, I'm still not going to get a matching pair. So what I need to do is actually multiply both of these equations by a factor to come up with a matching pair. So what I'm going to do is I'm going to multiply equation 1 by, say, 3. That's going to give me 3 times 3x is 9x. 3 times positive 2y is positive 6y, and 3 times 6 is 18. Okay, you might see where I'm going with this. This is now equation 3. I still don't have a matching pair there. So I'm going to multiply my equation 2 by 2 to see if I can come up with a matching pair. Now I've chosen these numbers because I know that these y values will then turn into a matching pair. That's specifically why I've chosen to multiply equation 1 by 3 and equation 2 by 2. Let's go ahead and do that. So 5x times by 2 is 10x. Positive 3x times by 2 is positive 3y times by 2 is positive 6y, my apologies. And 11 times by 2 is 22. Now I've got equation 4. And now, in fact, I do have a set of matching pairs with a coefficient of y. So now I can eliminate the y pronumeral from my equation. And what I'm going to do over here is I'm going to subtract equation, in fact I'm going to do equation 4, take equation 3. See how we go there. So 9x, 10x, I've actually got 4 take 3, so it's 10x, take 9x is 1x. In fact, let's stick with black. 1x. 6y, take 6y, it's eliminated. I'm left with equals 22, take 18, which is 4. So 1x equals 4, x equals 4. It's not always that easy, it just happened to work out that way. So I now have my x value for my answer on my set of coordinates, which is 4. I then need to go ahead and substitute that 4 back into either one of those equations, 1, 2, 3 or 4. Let's just go with equation 1 because it's nice and easy. So let's go ahead and put that in blue. It's now 3x, or 3 times 4, plus 2y is equal to 6. Okay, 3 times 4 is 12, plus 2y is equal to 6. Let's solve that by taking 12 from both sides. I'm now left with 2y equals negative 6. So I'm just going to zoom out here so you can still see the whole example. And I'm going to divide by 2 on both sides. And y is equal to, that's right, minus 3, giving me a final solution of your set of coordinates. Remember, it's your x value and then your y value. My x value is 4 and my y value is minus 3. Okay, again, that represents the intersection point between these two equations. Alright, so when we're solving simultaneous equations, that's what your answer is. That's what it represents. It represents the point of intersection between those two linear equations. Remember, those equations are represented with straight lines, and that's where your solution comes from. Alright, so hopefully that makes sense. Hopefully that was helpful. Again, I'll put some questions up for you guys to work through on DayMap, and try and extend yourself. If you've got any questions, please send them through and ask for help if you're not sure. Again, thanks for watching, guys.